I know you've probably heard of the term smart contract, but you might be wondering what is a smart contract? And basically, a smart contract is a piece of code that lives on the blockchain and executes certain functions. Okay? But how does a smart contract look like? So in this video, we are going to take a look at a smart contract, see how it looks like, or see how it's structured. All right, so here we have a smart contract. And if you wonder what is this is Remix. Remix is a online IDE for writing smart contract. Okay, so basically this is how a smart contract look like, and we are going to walk you through everything that is in this smart contract. So to start the smart contract, you have seen this comment on the top, and it says SPDX license identifier. So in this case, our identifier is GPL 3.0. And basically this specifies under which license is the smart contract identified, okay? And this is our license right here. So if your smart contract is not licensed, a good way is to say unlicensed here, right here. Instead of specifying GPL 3.0 or MIT, you might as well say unlicensed, okay? So the next line, it says pragma solidity, and we have greater or equal than 0.7.0 and less than 0.9.0. So what does this line of code mean? Basically, this line of code specifies the version under which the smart contract will be compiled. Okay, so for smart contract are compiled and deployed. So for the compiler to compile your code, it has to check if it's able to compile your code. So if your compiler is between this version and this version, that means it can compile your code. If your compiler, let's say you have your compiler is 0.6.0, and in that case is not between these bounds, that means that compiler will not be able to compile your code. So that's what this line of code means. It specifies the version of that version of that smart contract. So down here you can see this comment. Okay, so basically this is how everything is commented, is well commented in Solidity. So you have the normal comment, and here you have title, okay, of the smart contract, and you have dev. Okay, so this is for the developer who will come and check your code and will see, the developer will understand what your code does. Okay, so if here you see set and change owner, that means this smart contract sets and changes the owner. Okay, so going down the line, you see now contract owner. This is where everything happened. Okay, this is our smart contract now. So everything will be inside the smart contract. But now what do we have inside smart contract? We have our functions, our events. We also have our states. Everything is inside the smart contract. Okay, and if you see the opening bracket and the closing brackets here, and everything is inside that block. Okay, so the next line of code says address private owner, and at this point you don't have to know all these. Okay, all you have to see is, all you have to know is that in Solidity everything is statically typed. That means you have to specify the type of the variable, okay, or which value will be stored. In this case, we are going to store an address in this variable called owner. Okay, and this address or this variable is stored in the smart contract. Okay, and it's in storage. Okay, basically in smart contract we have storage and we also have memory. So memory is the memory storage, okay, is stored inside of a function, whereas storage is, a storage variable is stored in the smart contract and a memory variable is stored inside of a function. That means when the function stop executing, or when a function is done executing, the variable that has been stored in a function will be deleted, okay, because you're stored in memory. But a variable that is stored in a smart contract will stay stored in the smart contract forever. So in this case, we will see this owner will stay stored in the smart contract, but this other, just give me a second. You see this new owner will just be stored in the function. When the function stops executing, that will get rid of that. Okay. So basically, this is how we declare a variable in Solidity. So down on the line, we have an event. Okay. And you see here it says event for EVM logging, and EVM stands for Ethereum Virtual Machine, and it's the machine that runs the Ethereum blockchain. So right here, events occur when something happens to the blockchain. Okay, so let's say maybe in this case, let's say you have changed the owner. Okay, because that's what this function does. Let's say you have changed the owner. So whenever you change the owner, you can fire that event. Okay, yeah, and it's the same event. It says owner set. Okay, so when you set the owner, you fire that event to specify that you have done something to the blockchain. Okay, all right, so let's continue seeing this contract. After event, we have a modifier. Okay, and basically a modifier is also sort of a function. The modifier is sort of a function that restrict certain accessibility to a smart contract or certain accessibility to a function. Okay, so in this case, modifier's owner will require that the message sender or the person calling the function is the owner. Okay, and here you see this right here is going to be fired if this condition, I mean, if the message sender is not the owner, or if this condition is not matched. Okay, so basically this modifier is going to be placed at each function, at a certain function, so that when you call the function, before executing the function, we first check, okay, if the person who has called the function is the owner. Okay, and the owner has been specified up here. So if that person is the owner, we can execute the rest of the function. If that person is not the owner, we revert the function with this error, and the error will say caller is not owner. And that's basically the importance of a modifier, is to restrict or allow access to certain part of the smart contract to a certain user. Okay, so in this case, only the owner is going to call that function where the modifier is placed, and we'll see that down in the contract. Okay, so don't freak out. So next step, we have a constructor, and basically a constructor is a function that runs when you deploy the smart contract. Okay, and the constructor runs only once. Okay, by the time you are deploying your smart contract. In this case, when I deploy this smart contract, we are going to set the owner to message sender. Okay, so that means the person who deploys the contract will be the owner of the contract, and will emit an event. Okay, so that's basically the importance of the constructor, is to run once, and when we are deploying the contract. So if we are not deploying the contract, this will not run again, or will never run again. And that's basically what the constructor is. So next step, we have two functions right here. Okay, and a function is written just normally as a function, and sometimes it accepts some parameters, sometimes it has no parameters. Okay, so here we have a function to change the owner and a function to get the owner. And remember, some minutes back, we talked about this modifier is owner, and the modifier is defined right here. Okay, so when you see this modifier in this function, that means only the owner is having access to change the owner. Okay, so this is why we say require message.sender is equal to owner. Because let's take an example. Let's say you want to change the role of someone, okay, in a smart contract. And basically, you have to be the owner of that contract to give access to someone else to the contract. Okay. And I think it makes sense. That's why we have these modifiers. So if you are not the owner of the smart contract, you can't change the owner. Okay. And it makes sense, I think. That's where you see this modifier is owner. Okay. And so basically we'll do something if the person calling the function is the owner of the function. And we also have another function called get owner, and this will just return the owner, the current owner of the smart contract. Okay. So basically, that's how a smart contract is. So if you check this other smart contract, you see the same structure: license, version, contract. We have struct, proposal, and everything. But I'll cover the types in Solidity in another video. So this was just a video to talk about the layout or the structure of a smart contract. So yeah, guys, that was basically a simple structure of a smart contract. Hope you saw how a smart contract look like, and you won't be confused next time you hear about smart contract or you see a smart contract. So that's it for this video, guys. Thanks for watching, and I'll catch up with you in the next one.